Good evening, everyone. I'm Karthik Kumar Choleti, and today I'm presenting my research on Llama based user agent to mine EHR and patient generated health data and visualize vital sign trends and generate concise clinical summaries given by the physicians. Over the next 8 minutes, I'll walk you through our system architecture, data preprocessing steps, visualization tools, LLM summarization, and an interactive chat demo, concluding with next steps and lessons learned. Motivation. So clinicians today face vast amount of numeric and textual data in EHRs, vitals, lab results that are tedious to sift through. Our goal is to provide real-time trend detection and interpretation so that physicians can make faster, more informed decisions. By coupling clear visualizations with on-demand AI summaries, we bridge quantitative data and qualitative insight. So the system architecture, we ingest raw HL7 ORU ADT and CCDA messages, convert them to file resources via an interface engine, then store them in a happy fire server. A fine-tuned Llama 3.1 agent queries that server for observations. On the front end, we render interactive plotly charts and use the same LLM pipeline to generate concise clinical summaries or conduct a live chat session. So the dataset consists of three types of data: ADT, CCDA, and OIU. The ADT is admission discharge transfer, and CCDA stands for Consolidated Clinical Document Architecture, and OIU stands for Observational Result, where each dataset consists of different types of data of the patients joined in the different hospitals, which are recorded by the respective clinicians or physicians. So the data pre-processing. Before any analysis, we remove identifying information and apply different privacy measures. We normalize Ionic codes to human readable display names, correctly missing or inconsistent labels. Here we can't do any normal methods like data missing, like by replacing or by miss modes or something like. We need to take care while it needs to uh, we need to take care of the data preprocessing very strongly, and the observations are extracted per patient into the JSON, and timestamps are converted to Python data times and sorted, ensuring all trains reflect true chronology. The vital classifier, here the user's natural language query. For example, if we ask what's her pulse or what's the particular patient's blood pressure, so this kind of queries is first matched against a small keyword list. If no match, like we fall back to the FIV short classifier generated by Llama prompt that labels the question with one of our vital categories. This hybrid approach keeps classification fast and accurate. The visualizations engines like we use here, Plotly, to render time series charts. We can see this in the latest sessions, like in the next coming slides. Here, this is an example of heart rate visualization of a heart rate of a patient. This uses the Plotly to render time series charts. So here we added a green band for the normal range and orange band for orange dotted line with a threshold of plus or minus 3 as a warning zone, and red for out of bound values. We can see this more easier in the coming examples. So markers are labeled with values and status. We support both single patient views and comparative multi-patient overlays. So this is an example chart of multi-patient heart rates. For example, like here, I took a patient name of Ella Adams, heart rate over past 4 weeks. So the green shaded region marks 60 to 100 BPM, and orange lines are at 57 and 103 BPM, which highlights the warming buffer, and the red markers show true outliers. So you see annotations for her first abnormal and latest readings and a clear legend explaining each color. So this is a systolic blood pressure, a type of blood pressure. So in this multi-patient wave, we compare David, Lillian, and Joseph. So these are the three different patients of who have systolic blood pressures. So shaded normal zones give context, and patient's line is color coded by the shaders. So annotations flag first abnormalities and latest values, and making it easy to spot who needs immediate attention. So this is another one, like belongs to diastolic blood pressure, same which is visualized same as the systolic blood pressure. This is the blood pressure vitals of the patients, like comparing by combining both the systolic blood pressures and diastolic blood pressures. So this is a generated summary example, which is generated by Llama 3.1, which is given by a good prompt. So this is the actual summary generated of Ella's systolic blood pressure. Notice how it speaks directly to the clinicians, like skips extraneous detail, and it delivers a clear recommendation. We validated these against manual chart review to ensure clinical relevance. So this is a chat session. This is a screenshot of a live chat session. So here everything wraps everything into a console style chat. Here I selected a patient, like asking a question, and the agent classifies, summarizes, and plots automatically. Like we can follow up a question like, how's about diastolic blood pressure? Like here I'm asking you, the question is asked as a systolic blood pressure, and what is a heart rate. Like we can see in the figure, like I asked the question as what's his heart rate, and so we can follow up, we can ask it follow-up questions like, okay, so what's about the particular patient's systolic blood pressure or the respiratory rates. So it will reuse the context, drawing the appropriate chart and summary. So this is a demo screenshot, and here are the feature directions. Looking ahead, like we plan to extend beyond vitals to lab results and medication adherence, which builds a web GUI for broader clinical access, and which integrate with real-time hospital systems and continuously fine-tune the LLM on new data and user feedback to improve, which improves the accuracy of the model. So thank you for all your for your attention, and I'm grateful for the Professor Gamarov, and thanks for the support.